Welcome everyone. We're going to get started here now. It's about 1:04 Eastern Standard Time. We're going to do a session on getting up and running with Calico in an on-prem environment and some of the considerations that you'll want to account for when you're planning out your cluster design in on-prem environments. I'm Jonathan Sabo. I'm a Senior Solutions Architect at Tigera. For the agenda here today, what we have planned is we're going to talk a little bit about Kubernetes networking considerations. So things that you're going to want to take into account as far as Kubernetes in general, and then more specific with the Calico CNI, the Calico networking considerations that you want to decide for yourself before you start to deploy apps to your Kubernetes cluster. We're going to go through some of the details there, and then together we'll install a Kubernetes cluster, and then we will install Calico along with that. I'm going to use kubeadm for the cluster install. We support a lot of different self-hosted Kubernetes distributions, pretty much every one of them. OpenShift, Rancher, kubeadm, kubespray, which uses kubeadm. In pretty much every Calico is kind of ubiquitous when it comes to Kubernetes networking and network security. It's baked into most of the public cloud hosted Kubernetes offerings as well. And then we're going to explore Kubernetes with Calico networking, which kind of just go through and kind of observe Calico IP pools and some of the settings that you can take a look at and manage using Calico networking. And then we will take a look at a simple Calico network policy. Calico provides network connectivity and network security enforcement inside of Kubernetes. You can create policies using the Kubernetes metadata to target workloads and kind of separate them from each other. People refer to that as microsegmentation inside of Kubernetes. And then after that, one of the new things that has just been made available is the Calico Enterprise trial. And you can add your on-prem or your cloud-hosted clusters and join them to the Project Calico Enterprise trial. And so we're going to do that together as well, kind of walk you through signing up and then upgrading from an open source Kubernetes with Calico install to Calico Enterprise. And then that will allow you to try out some of the advanced use cases that are made available via the enterprise product, things like DNS policy, egress gateways, a lot of the visibility, observability, troubleshooting, and you get a chance to check out the UI and look at the Calico Enterprise flow logs, which are infinitely useful for troubleshooting connectivity issues. They also just came out with like Calico Enterprise 3.3. They have the ability to do packet captures and to target workloads using labels, and then get PCAP packet captures of those workloads, saving you from like SSHing into nodes and having to TCP dump everywhere. Makes it really easy to do. So just getting started, the Kubernetes networking considerations. Well, the first thing you probably want to decide is which CNI am I going to use for my cluster. I mean, obviously you should use Calico, but there are other choices, and you need to kind of decide hey, what are the system requirements for a particular CNI. Does my kernel support this particular CNI? And whether or not you want to use native networking technologies like like standard Linux routing, or you're going to use an overlay, doing encapsulation. Those are kind of some of the decisions that you'll want some of the things you want to consider. And then also, do I want to be able to do network policy? Not every CNI supports network policy. Calico implements network policy, so that's a great choice if you have security criteria that you need to comply with, or you have like multi-tenant clusters, or you want to separate apps from one another and kind of have the security around those applications that you're probably used to having via firewalls and things inside of the data center that are used to separate virtual machines or bare metal workloads. And then you're going to want to choose your pod sider. When you create your Kubernetes cluster and you pick a CNI, the point of the CNI is to be able to to be able to wire up the network connectivity for pods, and to be able to, Calico specifically will also allocate IP addresses for those pods and then make them available to all the other pods inside of your cluster. So you can you can deploy your microservices to the cluster, and they can talk to each other without having, they see each other from the IP address that the pod sees itself, without having to go through NAT or anything. And you have to kind of decide how many nodes are going to be in my cluster, and then how many pods are going to run on each node, and kind of account for the memory and the CPU utilization based on how many workloads I'm going to have inside of my cluster. And IP addressing is a finite resource as well, along with CPU and memory. So you have to kind of decide, how big is this cluster going to be? How many nodes? How many pods? Every pod gets at least one IP address. So you have to account for that up front. And then you're going to want to decide, the network that I use for my pod, is this going to be private to the Kubernetes cluster, or is this going to be externally routable? Am I going to expose the pod network to the networking gear outside of the cluster, or is it going to be the pod IP addressing will be private and only known to the nodes inside of the cluster? And then you also have to choose a service sider. These are kind of the two things that you decide when you go to create your Kubernetes cluster, whether you're using OpenShift, Rancher, kubeadm, kubespray. You're going to want to pick a non-overlapping pod sider and service sider. You're going to want to have two different networks for those. The service sider is going to be used to allocate IP addresses for Kubernetes services. Kubernetes services are basically load balancers. You're going to load balance to the pod IPs. They provide a well-known address to connect to microservices. And the pods themselves are very ephemeral, and they will be coming and going, and as they're launched and created and terminated, and they get different IPs over time. And depending upon the churn they can change IPs quite often. And so having a service in front of the pods allows you to load balance to the actual the pod workloads, the applications that you're deploying to Kubernetes, and provide a well-known address to talk to those microservices, and also service discovery via the DNS mechanisms inside of Kubernetes. Services themselves are implemented via kubeproxy, and you have a couple of choices as far as how the kubeproxy mode that you use, and depending upon which you choose, it could have performance impacts on your cluster. By default, I believe IP tables is the default mode, but there's another mode called for IPVS, and you'll see as we get into this, there's some links to some blogs that we've done in the past on the performance characteristics of IP tables and IPVS, and when you want to you might want to consider moving from IP tables to IPVS as far as services when you reach like thousands of services. So it kind of depends on like how many workloads are running inside your cluster and how many services you have. When you start to reach a certain scale, you might want to consider one of these options. From the Calico networking considerations, Calico has several different data planes. We've been working on our eBPF data plane, which is available in Calico open source today. We also have the standard Linux data plane, and we also have recently open source Calico for Windows, which is another Calico data plane that we make available to you. So depending upon the OS environment that you're working on, if you have like one of the latest, greatest operating systems and you have a newer kernel, you probably have the ability to use the eBPF data plane, which has some performance and scalability benefits, along with some additional observability and some additional superpowers like direct server return and the not having to actually even use kubeproxy. The standard Linux data plane, that's what we're going to be using today, is Calico. What it does is it basically, it's not really in the data path. We're just programming the Linux kernel. So you get to take advantage of the native, the standard Linux networking using routes, route tables, and being able to use the same tools that you've been using for years to troubleshoot your network, to troubleshoot Kubernetes networking without having to do network encapsulation, which is takes us to the next point here. Do I need network encapsulation? It depends on whether or not all of your nodes are on the same subnet or not. If your Kubernetes cluster is split across multiple racks and the racks are on different VLANs, i.e. not on the same subnet, you'll need to be able to either integrate with the routing topology, or you'll have to do some tunneling across subnet. We have a couple of different encapsulation protocols that we support. We support IP and IP and also VXLAN. And so if all of your nodes are on the same subnet, you can turn off encapsulation. You don't have to do any encapsulation, because all of the nodes will be able to connect to each other and they'll be able to route the packets for the pod sider amongst each other. But if they are split across different subnets, across different racks, you'll want to take a look at the encapsulation options for Calico. And then the third addressing consideration is, what do I use for the initial IP pool sider? So a lot of times when I work with customers, we'll see that they will not really take this into account. They will have picked the pod sider, they'll pick the service sider, they'll sign a /16 for the pod sider, and then another network /16 for the service sider. And then by default, they'll use the entire /16 for the initial Calico IP pool. I think you will want to, if you choose to use if you use a small segment of your IP of your pod sider for your initial Calico IP pool, that sets you up for success later on, and it makes it really easy to take advantage of some of the Calico superpowers, like being able to have more than one IP pool, being able to create multiple IP pools, and then assign a particular IP pool to a Kubernetes namespace. And also it allows you to, it sets you up for some of the enterprise features like egress gateways. Calico has, it implements its own IP address management, Calico IPAM, and you can create these things called IP pools, and they have some configurable settings. If you start off with, say, a /24 for the initial IP pool, which is what we're going to do here in just in a little while, you can create more than one. You can create multiple IP pools, and then you can assign them to a particular namespace. You could say, hey, the pods that are launched to the dev namespace, they get IP addresses out of this /24, but the stage namespace and the prod namespace, they get IPs out of these different networks. And that kind of, it makes it really easy to integrate with network security controls outside of the cluster, should you choose to peer with your top of rack switches. As the traffic leaves, you can, your firewall admins and your networking team can have they'll know that, hey, this workload, it has this IP address, and it obviously came from the dev namespace. So the dev workloads can only talk to these things past the firewall. So it just makes integrating with the traditional network security controls outside of the cluster a lot easier to do. Another consideration is, what is the IP pool block size that I should use? The default is /20 is a /26, and if you're working with your network team, they might be particular about the block sizes that are allocated out of your IP pool to a particular node. And then you have to decide, hey, am I going to keep my private cluster, or am I going to keep my cluster private, or am I going to integrate with the networking topology and peer with the top of rack switches and things like that? When you do that, you'll want to disable NAT outbound. By default, when traffic leaves a particular Kubernetes node, it's going to get source natted to the node's IP address. So the traffic leaving the cluster will look like it came from one of the Kubernetes nodes. Calico enables you to peer with top of rack switches, and then you can turn that off, and then you can have your pod sider and your service sider become routable. And then you don't have to do NAT outbound, and you can manage that on a per IP pool basis. In addition to the network connectivity and the IP address management, Calico also implements Kubernetes network policy. Calico network policy is a superset of Kubernetes network policy. Calico network policy, it allows you to secure applications by enforcing what network traffic is allowed or denied between different workloads inside of the cluster, so east-west, and also ingress and egress, so north-south, inside and outside of the cluster. And you can do that using label-based rules. Labels applied to pods, labels applied to namespaces, labels applied to service accounts. The labels, the label management for things like namespaces and service accounts, they can be controlled by RBAC and kind of held as an administrative function. So you have pretty tight security around what can talk to what inside of your Kubernetes cluster. And that's one of the reasons why it's really important. As teams are moving more and more workloads into Kubernetes, you're seeing a lot of collaboration amongst different teams that traditionally probably would have been a little more siloed. You're seeing a lot of interest from the security folks and the networking folks that are typically managing the network security for an enterprise using things like firewalls. So they're going to be involved in the planning and the deployment of the Kubernetes clusters and platforms that you build for yourselves. And they're going to want to have a way to implement the security controls that traditionally would have been implemented via firewalls and things like that, or IDSs and IPSs. Inside of Kubernetes, because the firewalls, they don't have any view into the cluster, depending upon how you configure it. So Calico gives you that ability to create a network policy that will allow you to segment workloads inside of your cluster. It's a label-based mechanism that you apply to workloads, and it will follow your pods around and around and apply that network policy to the applications that you deploy. Let me think if there's anything else I wanted to touch on here as far as that goes. Yeah, it's just a Calico network policy. It's going to allow you to enforce those security controls and make it possible for you to move applications into your cluster faster. And being able to have that control over network traffic allows you to comply with your security criteria and will speed up your ability to release your applications to your platform. The security team will be happy, the networking team will be happy, and your deployments will continue to flow. What we're going to do after we get our cluster up and running is we're going to deploy a sample network policy example. What we see here is this is like a typical application that you might deploy to a namespace inside of your Kubernetes cluster. It's got a front-end web interface, a couple of different APIs that the web UI talks to. They implement like the business logic of your application, and then the APIs talk back to a database inside of the cluster. And by default, without network policy, every workload can talk to every other workload. Pods can talk to every other pods, and without having, if you don't have network policy. And what you can do with Calico network policy is segment those workloads from one another. What we have shared today is just kind of re-implementing a well-known segmentation pattern that most people are familiar with in the data center. The concept of zone-based architectures, the ability to have like a DMZ that so from like least secure to most secure, have like a DMZ zone that takes inbound traffic from the internet, or maybe from the ingress for your cluster, and then a trusted zone where you would allow inbound access from the DMZ and not from the internet, and then allow outbound access to the database, the most secure zone, where you would store the keys of the kingdom, your databases, and things like that. It's just an example network pattern that a lot of people who are just new to Kubernetes or coming to Kubernetes from traditional network security in the enterprise worlds that they're used to seeing. Calico network policy also supports the idea of global network policy. So you can very easily create a policy for your entire cluster and just simply say, we're just going to do default deny across the entire cluster for every namespace, kind of implementing zero trust networking as far as network policy goes. Kind of an evolution on the paradigm of zone-based architectures. Instead of trusting all the workloads inside of a particular zone, trusting each other, there's just zero trust amongst every workload, and just having to whitelist the allowed connectivity. So like a least privilege network policy design. And then we're going to talk a little bit about Calico Enterprise after as well. There is a free trial at tigera.io/trial. And hopefully if we have time, we'll kind of go through that process together. It will enable you to go to like docs.tigera.io, and then you can see a lot of the advanced policy capabilities, the ability to do policy auto creation. We also have the concept of preview and staging. You can create a stage policy, kind of a learn and lock or try before you buy, or like a permissive mode. You can create a network policy and stage it and see, hey, this is what would this do? Would this deny traffic or allow traffic? And then once you're happy with it, you can promote it to an enforced policy where it would actually be doing the denying and the allowing. A lot of policy troubleshooting tools, some security controls around egress access, traffic leaving the cluster, accessing things outside the cluster like databases or APIs or other services that are inside your data center that are running on virtual machines and things like that. And then some advanced like threat detection and some security team controls, and also collaboration around network policy to basically promote safe self-service network policy collaboration amongst teams, the DevOps teams, the dev teams, the security teams, the network teams. And we'll see some of that in just a moment. I'm going to grab this link and drop this into the chat if you're welcome to follow along. This should be public GitHub repo, and we're going to kind of run through standing up a Kubernetes cluster and then installing Calico using our new operator-based installation, and then kind of explore the cluster using and look through Calico. And then we're going to upgrade this cluster. So we're going to start out with open source, and then we're going to register for the trial, and we're going to upgrade our cluster to be Calico Enterprise, and kind of take a look at how does that look, and what is that? What's the user experience around that? And then we'll be able to use all of the enterprise and policy enforcement things like using DNS names and policy, and a lot of the being able to have a user interface to manage network policy, and also the visibility that the Calico Enterprise flow logs and audit logs and DNS logs all give you. All right, so let's get started. So this is kind of just a bit of a recap from the slides. We're going to talk about our Kubernetes network configuration and then our Calico networking configuration. So we mentioned kind of earlier on, there's a couple things you need to decide up front before you install Kubernetes. You need to pick a pod sider, a service sider, and then you get to choose a kubeproxy mode. If you don't choose, it's probably going to be IP tables. I believe that's still the default. And so what we're going to choose is we're going to select a pod sider of 10.48/16, and then we're going to pick a non-overlapping network 10.49.0.0/16 for our service sider. And then as far as the Calico considerations, we're going to do the standard Linux data plane today. I encourage you to check out the new eBPF data plane, where we actually just released a blog, I think today, on using eBPF with in AWS with the bottle rocket in EKS, and I think that we're doing some performance blogs pretty soon. So keep an eye out for that. The initial IP pool that we're going to assign our cluster is 10.48.0.0/24. So a subset of the network that we have here defined for our pod sider. And we're going to do that so we can create multiple IP pools. You can change things after the fact if you happen to have already started out with like the whole pod sider for your IP pool. There's a documented procedure for swapping out the IP pools. Is just if you decide ahead of time just to do a segment of it, it's just faster and easier for you. And we're just going to leave some of the defaults. We're going to keep the default block size /26. We're going to leave NAT outgoing enabled. We're not going to be peering with any top of rack switches today. We will probably come back and do that in another version of this particular talk. And then we have an additional IP pool. We'll see if we get to that. Let's see, we got a half an hour left. All right, so the first thing we need to do is we need to install Kubernetes with Calico using kubeadm. And so you can see here, we're going to pick Kubernetes 1.18, and we're going to install this on Ubuntu. So let's just get going on this stuff. I'm going to come over here to my self-hosted. My on-prem environment today is actually in AWS. It's just VMs. It's the same thing as you would be doing on-prem. It's just quicker for me to get going with these VMs. So let me just create these files on each one of these Ubuntu boxes. Install.sh. And if you have some virtual machines in your environment, whether that's like some VMware vSphere VMs or just bare metal nodes, it'll be the same situation. So I'm just going to go ahead and install each one of these really quickly. All right. While that's going, I'm going to take a look at the questions. Victor's asking, I wonder if you can show how to limit bandwidth in pods. Just a little example and demo. I'm not set up to do that today. That is actually something that you can do. The Calico comes with I believe it's called, it might be traffic control. But yeah, you can do quality of service to some degree using the standard Calico node capabilities. We're not going to do that today, but I will keep that in mind for next time. We have what we're going to show today is how to enforce network policy and how to upgrade your cluster to the Calico enterprise trial. We have another question. Can Calico support multi-user CNI kind of capabilities, Maltus? Yeah, absolutely. When our OpenShift install, I believe utilizes the Maltus as well. And Calico Enterprise has the capability to do multiple interfaces for like telco use cases. And I believe Maltus is utilized in that scenario as well. So yeah, we can have multiple interfaces and leveraging Maltus. Let's see here. All right. This is going all right. So after we've got the Kubernetes stuff installed, then the next thing we need to do is we need to actually initialize our cluster. And we're going to create a, we're going to use kubeadm to build our cluster, and I'm going to create a Kubernetes configuration here. And you can see this is where I'm defining upfront my service sider, my pod sider, and I'm picking my IP or my kubeproxy mode right here. If I wanted to do IPVS, I would just change IP tables to IPVS here. So let's see over here. And hopefully, let me make sure I got everything in here. All right, let's give this a shot here. So let's do this. I'm gonna grab the configuration and just save this here into a file. And then we're going to reset the cluster. This shouldn't be necessary. This is like a brand new VM. But if you're running through this multiple times and you want to kind of reset everything, this is how you do it. Use kubeadm reset, and then you can initialize your cluster, and we'll let that go. And then once we're done, it's going to output the command. So commands that are going to let you set up your kube config to talk to your cluster, and then it's going to give you a kubeadm join command with a particular token. Don't just copy this out of the GitHub. Yours is going to be different. Everybody that installs their token is going to have a different one. And then down here, we're going to join the clusters. We're also going to install the Calico Cuddle. This is the Calico CLI tool that allows us to manage network policy with open source Calico. One of the benefits of upgrading to Calico Enterprise is you get an aggregate API server that makes a lot of the management of the Calico resources possible just using just kubecuddle. All right, let's come back over here. All right, so you can see here we go. We're setting up our kube config, and then we're going to copy this token, this kubeadm join command, and we're going to run this on the worker nodes, and then run this on the worker nodes. All right, and then so we should see. All right, so we got a 3-node cluster going. We have a controller node, and then we have 2 worker nodes. You can see that they're not ready yet. And if we look, when we get the pods, we'll see that we've got a couple pending. So we need Calico to be installed so we can assign IP addresses. So let's come back over here and just kind of keep going down the instructions. Before we install Calico, let's install the Calico CLI tool. So we're going to grab the latest, greatest. Calico, the open source version is I believe is 3.16.4. So we're going to go ahead and just pull that down. And then we are going to make it executable and then move it into our favorite bin directory. And so now we have the Calico Cuddle CLI. All right. And that's installed on our master node. And what I'm going to do now is going to create this the configuration file for the Calico CLI. Just do that real quick. And I'm going to point it at the kube config that we just had created for us. So I'm going to put this in here, save that, and then we're going to move it into the default location where it knows to look for things. And so we're going to make that directory, and then we're going to move it into place. And now I should be able to do things like Calico Cuddle get or Calico Cuddle node status. Oh, we have to install Calico first, though. That's right. All right. So we've already done each worker. We've already actually gone through. You don't have to reset anything if it's a brand new VM, but if you want to, you can. And then you're going to want to run the join commands on each one of your worker nodes, and then it will come over here and it'll tell you, hey, we're ready to go. You've joined your worker nodes to the master. And then we are going to install and configure Calico on the master node. So the first part is we're going to use the operator-based installation. So this is Calico, installing Calico for and managing the lifecycle of things using an operator. So the first part is let's install the operator. All right. And then we're going to download the custom resources.yaml. The instructions on our docs and like projectcalico.org, it has you just apply it. And that's fine if you want to just get up and running quickly. But we want to make some changes to the initial IP pool. We want to change it to be a subset of our pod cider. We want to turn encapsulation off. And we're going to we're going to keep net outgoing and keep the same block size. The main thing is I want to use a small section of the pod cider. So let's pull this down first. And let's take a look at it. All right. You can see that the default configuration is it gives you a different cider, and it uses VXLAN cross subnet. So it kind of like sets you up for like the most likely to work in your environment configuration. I'm just going to copy this whole thing. Let me do that. Let's go ahead and delete all this. Paste this back in here. Just make sure look over, measure twice, cut once. All right, 10.48.0.0/24. All right, that looks like what we want to do. And now we are going to apply that custom resource that we downloaded and we just edited. Let's go ahead and do that. And let's take a look and watch Calico come up. We can watch the pods. The Tigera operator is going to set everything up for us. So we're gonna just kind of wait here for a little bit. I'll take a look and see if we have any more questions. Not yet. All right, good. All right, check time. We got 20 minutes left. All right, that's coming up. Let's take a look down here. So next thing, this is just straight from our docs. We're going to remove the taints on the master so we can schedule pods to it as well. So we'll come down here. And now we're going to just take a look and see, hey, are the nodes ready? And what do the pods look like? So the nodes are not ready. Before they were not. The IP addresses, you can see that the Calico Kube controller and core DNS and friends have been assigned IP addresses out of the Calico IP pool. And you can see some of the other stuff is like host networked. Let's keep coming down here. So now let's take a look at, we're going to use the Calico CLI tool to kind of explore our cluster and take a look and see what's going on. So we have chosen to do no encap install, and we have disabled, so we're doing just straight up no encapsulation, BGP routing between the nodes. And you can see that the nodes have established a full BGP mesh, IBGP, between each other. I'm on the master, so you can see the status as it sees this world. Those are the IP addresses of the two worker nodes. And you can see it's like .214.66 over here. We keep coming down here. You can see this is what you should see. You should see up and up. And as long as the nodes are on the same network, you're good to go. Let me see here. There's a question. When you set up the network, you set it up to encapsulation none. Is it the same as using network host on the container? I don't think it's quite the same thing. It's when you do no encapsulation, you're saying that one of two things are true. All of the nodes are on the same subnet, and they can communicate with each other without having the physical network that it's taught, like having it to know about the private the IP pool that you've assigned for your pods, or you've chosen to actually peer with your top of rack switches and then made that pod cider available and known to the network, in which case at that point you can have routing work for you. You can have some of your Kubernetes nodes on one subnet and some of your Kubernetes nodes on another, and then you would be able to and still be able to do the full BGP mesh, or be able just to have routing from pod to pod across the different nodes without having to do encapsulation. I wanted to come here and take a look at the IP pool so you can see. So there, you can see here just Calico cuddle get IP pools. This is the default one that's configured, and you can see that it's the /24. And this is all the nodes are going to be allocating out of this particular IP pool for pods that get launched to them. And you can see here that we've got the same settings that we defined in our custom resources.yaml are magically appearing here inside of our first IP pool. The operator creates this for us. We've got our initial IP pool of 10.48.0.0/24. You can see the block size. You can see the IP mode is never. Now outgoing is true. So as traffic leaves the cluster, it's going to get source natted to the IP address of one of the nodes. And let's keep coming down here. And also, yeah, so we can also have visibility into the IP address utilization of that pool. You can see that right now we're using 3 IPs. You can see that we have a /24, so we have 256 available IPs. It means across our cluster, we can have 256 pods, and you can see the percentage free over here. If we dig a little deeper, we can actually look into the different blocks, and we can see that we have a 3-node cluster, and the way Calico IPAM works is it's going to take a block out of our IP pool and it's going to assign it to each cluster initially. So one of them got 0.0/26, another one got 0.192/26, and another one got 0.64. So each node got its own block out of that IP pool, and you can see that we're using one of each of these here. And so it gives you a way to monitor and kind of keep track of your IP address utilization across your Kubernetes cluster. I think it's kind of nifty. And then one of the things that so we were talking about, so that up to this point we've been talking about networking and networking for Kubernetes. The other superpower that Calico has is the ability to do network policy. So we can we can say this pod can talk to this pod, but not this other pod. So maybe dev can talk to dev, but dev can't talk to prod. Those are the kinds of things that you can enforce using network policy in Kubernetes and using Calico network policy. I'm just going to quickly kind of take a look and see, hey, do we have any network policies running? Let me just copy this. All right, come over here. And we can see that we don't have any network policies. And we also don't have any, and you can see that network policies are namespaced, but global network policies are not. Global network policies are policies that apply to your whole cluster. So you could say, hey, the whole cluster is allowed to do DNS, but the dev namespace is not allowed to talk to the Twilio API, things like that. And you can segment workloads inside of your cluster using both of these constructs, both network policies and global network policies. Maybe you want to allow developers to manage the network policies in the namespaces that you've allocated for them, but you don't want them to be able to control the network policy for the entire cluster. You can control who can edit the global network policies and then the network policies for all the namespaces or a particular namespace using standard Kubernetes RBAC. And that kind of allows you to enable self-service of the network security controls and be able to quickly or more quickly release to your clusters. A lot of times we have customers, they'll have their Git repo, and it'll have the code that they're going to deploy. They're going to containerize and deploy to Kubernetes, along with a build specification, a Travis.yaml, a Jenkins file that tells the build system how to build how to containerize and how to build the application, how to containerize it. And then in the same repo, they'll have the Calico network policies that secure that microservice, and they'll version those right along via the life cycle of that application, and just kind of manage all the security as code, policy as code being released to your cluster right along with the rest of everything else. So inside of our in this repo, we have the YAML implementation, or the YAML representation of the firewall zone policies that we showed in the slides earlier. I'm just going to apply these quickly. Oh, let's see this. I'm going to apply these quickly once I clone this repo. Let's do that. All right. So let's take a look at this. I'm going to come down here and just make these smaller so we can look at the YAML files together. So in this repo, we have a firewall zone policies, and you can see these are Calico network policies. You can see this is a network policy, and this is the DMZ policy. And this is going to apply to all the pods and the namespace that we deploy this into that have the label firewall zone equals DMZ. And we're going to allow inbound access from a particular network CIDR. And then we're going to allow outbound to the trusted zone and to a logging app as well. So, and then we have our trusted zone that we've defined, and you can see that we're allowing inbound access from the DMZ, and then we're allowing ingress also from the trusted zone. So everything is in the same zone can talk to each other, and we're allowing inbound from the DMZ. And then we're going to allow outbound to everything in the same zone, and then also to the restricted zone. And then the restricted zone is here. So all the workloads in a particular namespace that have the label firewall zone equals restricted are going to be able to accept inbound connectivity from the trusted zone and also amongst each other inside of the restricted zone. So let's just go ahead and apply that. Actually, we're going to want to use Calico call for that. We come down here and make sure we're following our instructions right here. All right, getting ahead of myself. So let's go ahead and apply the policies, and then let's take a look at them. Calico network policies. All right, and you can see that what we've done is we've applied that zone-based architecture into the default namespace. And so we have a DMZ zone, a restricted zone, and a trusted zone. So we've kind of modeled the same segmentation pattern that you might be used to outside of your cluster, inside of a namespace inside of Kubernetes. So quickly, we have 10 minutes left. Let's see if we can make this happen here. If you go to, after you're done and you go to tigera.io/trial, you'll see that you can sign up for the Calico Enterprise free trial, and you get to pick your journey. You can have a completely hosted sandbox trial where we give you some labs and things like that to go through. Or one of the new things that you can do is you can actually upgrade your cluster on-prem, your Rancher cluster, your kubeadm. There's a couple of different supported cluster types. We've got Rancher, Amazon EKS, and today I'm doing kubeadm. You can sign up, and then you can upgrade your cluster that you have in your data center or in your cloud and have that joined to a hosted UI. And we're going to go through that today. So once you sign up for the Calico Enterprise trial, what you'll see is you'll get it'll be directed over here. It's like success. Your login credentials will be emailed to you. And then you get an email saying, hey, we're going to email you your login credentials. And then you get the actual email with the ability to do the installation. I'm going to delete this later on, so don't have me in the meantime. So let's try to upgrade our cluster right here. So we've got kubectl get pod -a. And what we're going to do is we're going to upgrade our open source Calico cluster to Calico Enterprise, and then we're going to take a look at Calico Enterprise. So we should just be able to paste this into our terminal. And the script that we're running here is going to upgrade our cluster. It's going to change the Calico node daemon set to be our Calico Enterprise product. And it's going to, at the end of this, is going to give us the information that we're going to use to log into the UI. And we'll get to kind of see how the enterprise product gives you the ability to view all of the endpoints in your cluster, all the policies that are applied, the DMZ, the restricted zone, the trusted zone that we just applied. And it's going to allow us to see all the flows inside of our cluster, which are like one of the most important things as far as being able to troubleshoot network connectivity inside of Kubernetes. While this is going, we'll take a look at some of the questions. So Ramesh and Manish are asking about IP mode. IP is it's IP protocol 4, and what it is IP encapsulated in IP. So the pod CIDR, the nodes, so the nodes in a particular subnet will be able to route packets amongst each other without having to do encapsulation. But when you're on a different subnet, you need to you're going to have to use an encapsulation method. IP is a very low overhead encap protocol, and it's just IP inside of IP. It's IP protocol number 4. The other encap protocol that is available is VXLAN, and that's great for places like Azure where you can't use BGP. It's also apparently the default install for our open source product. You saw that the first thing when we pulled down the custom resources.yaml, we saw that it was doing VXLAN. We removed that and we changed to no encap because my VMs are all on the same subnet. Let's see here. Can the Calico definition be packed as part of a Helm chart? Any special consideration, recommendation on that? Yeah, we actually do have a Helm chart. We call it the Helmerator. The Helm chart installs the operator, and then the operator installs itself. So it's kind of like a little meta. But yeah, there is, I believe, a Helm chart available in our docs. I prefer the operator personally, the operator installation. But if you are, we do have Helm available in our docs as well. And another question, which takes precedence, native K8s network policy or Calico network policy? Well, it depends. One of the things about Calico, or excuse me, Kubernetes network policy is it's not ordered. And so it defaults to an order of 1,000, and Calico is ordered, and you can have lower orders. So you can you can decide, you can say, hey, this Calico policy is going to be applied before this Kubernetes network policy by making it a lower number than 1,000, or you can make it after the Kubernetes network policy. And we also have the ability in Calico Enterprise, which we're going to check out right now. And if you guys are able to copy and paste this, feel free. We're going to come back over here to our UI. I'm going to paste this in. And so you can see we get access to the Calico Enterprise UI, and we're going to copy and paste this token that's printed out. And so see if I can copy and paste this with me today. All right. We can log in, sign in. All right, and I'm not going to say that. And so now you can see this is the Calico Enterprise user interface. You can see that this is the cluster that we just provisioned. I can see all the policies that I've applied, all the endpoints. I'm starting to get stats here. Let's take a look at this. We can take a look at the policies. You can see that we've got our DMZ policy, our trusted policy, and our restricted policy. If we click on this little eye, we can see all the allowed traffic, the allowed denied in the past. And we have the ability to visually edit the policy. You can see that this policy is deployed to the default namespace. And you can see this is the same. This is the visual representation of the YAML representation that we were looking at earlier. Just kind of come down as we make changes to everything. You can see you get an audit log, and you can see all the changes over time. You also have that same ability inside of the policy. If I was to just like edit something, let's see here. Let's add another allow rule. We're going to allow any protocol, and just save that. I'm going to move this up here. All right, and then I'm going to enforce that. When you come down, you can see really quickly here. Just refresh this. You can see so we have audit logs per policy, but also across the entire cluster. You can see here. One of the other things you can do, you can see all the endpoints in your cluster. So these are this is the private cluster that I have hosted in my data center. And it's what it does is it connects outbound to a management cluster that we manage for you. And you have access to this UI. You can see all the nodes. You can see the network sets inside of your cluster. You can see that you actually have, in addition to the cluster that you join, there's another cluster available for you to browse to. And it's set up with a bunch of different labs. If you come over here and you look at the policies, you see that we have some tiers and some other policies applied for you to test out some different use cases. I'm gonna come back over to my cluster that I joined. So this is the Calico Enterprise multi-cluster capabilities. You have the ability to manage multiple clusters from a single pane of glass, and you have the ability to kind of get a sense of visibility and troubleshooting. You got compliance reports, alerts. But I wanted to show you the time we have left, the Kibana dashboards that we have and the flow logs. This is like one. So a lot of times I'll see people want like, how do I see allow and deny traffic? What do I see what's going on inside of my cluster? That's what the Calico Enterprise flow logs give you. You can see here that we'll take a look at one of these workloads. So typical flow logs are like the 5 tuple flow logs. You have source IP, destination IP, source IP, destination IP, source port, destination port, and protocol number. And Calico Enterprise gives you 26 or 27 different additional pieces of Kubernetes metadata that we infuse in the flows. So you get the source and the destinations, but you also get the workload names, an aggregation of the workload names. You get the labels that are applied to the workloads. Let me pick a different flow. You can see that we've got the labels that are here. So this looks like it's a DNS lookup probably. Yep. So this particular workload is doing a DNS lookup. You can see the destination port. You can see the labels that are applied to it, to the source and the destination, and you can see the policies that are governing what it can talk to, and then whether or not it's allowing or denying that traffic. And you see that this particular flow was allowed by the policy in the platform tier that says allow kubedns. Let me stop here and come back over here. We just want to, again, there's a couple of questions on here. How is Calico Enterprise different from the Tigera product? Tigera is the creator and maintainer of Project Calico. We also have an enterprise product that is Calico Enterprise. I encourage you to try it out for free. You can join your own clusters and run through all of the enterprise use cases that we have in docs.tigera.io. There's a lot in there. Definitely take a look. The policy auto creation, the policy preview, the staging, the troubleshooting tools, the egress access controls, all of that stuff you can do in your own data center with your clusters using the trial, or you can choose to use our hosted trial. We also have some additional upcoming training events. Later on this month, we've got secure networking for Kubernetes in an EU time zone. So if you wake up way earlier than me, you have one that will be in your time zone. And then we have network policy with GKE. We're doing get set for Kubernetes network with success with Carbon and Calico, enterprise security controls for Kubernetes, getting up and running with Calico on your Rancher Kubernetes server. So you might be doing Rancher on-prem, which is one of the supported cluster versions for our enterprise trial. And also, I'm going to be doing the Calico Enterprise multi-cluster management federated identity and services. So if you have lots of Kubernetes clusters and you have to control which workload can talk from one cluster to another, or you want to extend services across clusters without a service mesh, you can do all that with Calico Enterprise. Well, it's 2:01. We're out of time. Thank you, everyone, for your time today. Hopefully you found it useful. And I encourage you again, sign up for the trial. It's trial tigera.io/events for all of the upcoming events. Keep an eye out. Thank you for your time.